नमस्कार मित्रों, मैं आप सबके सामने हाजिर हूँ अपना अगला वीडियो लेकर। और आज के इस वीडियो में हम सीखेंगे व्हाट आर इक्विवेलेंट फ्रैक्शंस, कंपेयरिंग एंड ऑर्डरिंग ऑफ फ्रैक्शंस एंड एडिशन ऑफ फ्रैक्शंस। सो लेट्स स्टार्ट। सबसे पहले बात करेंगे इक्विवेलेंट फ्रैक्शंस की और व्हाट आर इक्विवेलेंट फ्रैक्शंस। Different fractions, if I have to give the definition, different fractions that represent the exact value, different fractions that represent the exact value are called equivalent fractions. For example, if I say two three fractions, if I write 1 by 2, 2 by 4 and say 3 by 6. These three are equivalent fractions, and how? I'll explain you. Let me explain you with the help of a diagram. Supposingly, I'm having this rectangular figure, and if I say 1 by 2, that means one part out of total two parts. So can I represent it like this? One part out of two parts. This is 1 by 2. Supposingly I need to represent 2 by 4. So let's make the similar rectangle once again, and it means 2 parts out of 4 parts. So total number of parts are 4 and 2 parts are being referenced. So supposingly I make it like this, which means 1 out of 4, 2 out of 4, 2 parts out of 4. And suppose I say 3 by 6, so let me make another rectangle, a similar rectangle, make it into 6 equal parts. So how can I do that? Like this I can do. And then 3 equal parts out of 6 parts. This is 3 representation of 3 by 6. So these are the different looking fractions, but they represent the similar values, right? So how they represent? Supposingly, this is total 2 parts out of 1 part, 1 part out of 2 parts, 2 part out of 4 parts, 3 parts out of 6 parts. So how are they equivalent fraction? We need to understand that. Suppose I divide the numerator and denominator with the same value, 2 by 4. This is numerator, this is denominator. And if I am in any fraction, if I am dividing the numerator and denominator with the same value, it does not make any change to the fraction. So suppose I divide it by 2 and suppose I divide it by 2. So if I am dividing the numerator and denominator with the same number, 2 divided by 2 is 1, 4 divided by 2 is 2. So what I got? 1 by 2, the same. Similarly, if I divide 3 by 6, 3 is the numerator, 6 is the denominator. I divide 3 by 3 and 6 by 3. So this would be 1 and this would be 2. Again I have got the same. So all these 3 fractions are finally giving the value as 1 by 2, 1 by 2. That means the same. All 3 fractions are same and all 3 fractions are the equivalent fractions. You saw this method. I'll tell you one more method. Suppose 1 by 2 was the fraction taken earlier. Now if I I told you that if I divide the numerator and denominator of a fraction with the same number, it does not make any changes to the fraction. Similarly, if I multiply the numerator and denominator with the same number, it does not change any, does not make any change to the fraction. So, supposingly if I multiply 1 by 2 the numerator and multiply the denominator also with 2, it comes 2 by 4. If I take 1 by 2 again, if I multiply 1 by 3, the numerator by 3 as well as the denominator by 3, it comes out to be 3 by 6, which gives this. So 1 by 2, 2 by 4 and 3 by 6 are equivalent fractions. This is how the equivalent fractions are being formed. So there are two methods to form or to find the equivalent fractions. Method number 1, two methods to find the equivalent fractions. Two methods to find equivalent fractions. Number 1, multiply the numerator and denominator with the same number. And number 2, divide the numerator and denominator with the same number. These are the two methods to find fractions equivalent to a given fraction. I hope I am clear with this. Let me tell you one more thing. Dividing the numerator and denominator with the same number is also called simplifying the fraction. Simplifying the fractions. So, simplifying the fraction is by dividing the numerator and denominator with same number, and this can be done repeatedly unless you get the least value. I will be discussing this little later, but this is fine. So, let us take some examples of equivalent fractions. First, let's write a question. Fill in the boxes with the correct numbers to make the fractions equivalent. And first part is 4 by 6 equal to 18, and here is a box given, and we have to find that what value will come here. So what we will do, we will first, to find the equivalent fraction, we know that there is a method where we have to multiply the numerator and denominator with the same number. So if I look at this, I know that if I multiply 6 by 1, it will give me 6. If I multiply 6 by 2, it will give me 12. And if I multiply 6 by 3, it will give me 18. This is what it is. So if I multiply 6 by 3, I get 18. It means if I have to multiply the denominator by 3, which means I have to multiply the numerator also by the same number, that is 3. So if I write 4 by 6 here, and if I multiply 6, that denominator by 3, I get 18. So similarly, I will be multiplying the numerator 2 with the same number. So 4 3s are 12. It means the value which will come here is 12. So we can actually do it orally by 6 3s are 12. So 4 3, 6 3s are 18. So 4 3s are 12. Right? And supposingly if I take a number B part 3 by 8 equal to 15 and a box over here. Now what should be the value which should be written here so that this fraction becomes an equivalent fraction of this fraction. So if I look at this numerator, 3 5s are 15. 3 5s are 15. So if I multiply it by 5, I get the numerator 15. So if I multiply the numerator by 5, it means I will be multiplying the denominator also by 5. So 8 5s are 40 is the answer. Let's take one more question, I think, and then we'll good to go. C part, question number 18 by 27 equal to, yes, here the value is smaller. So 18 by 27, and I need to find the equivalent fraction to this. Now 27 should be divided by 3, then I get 9. So 3 9s are 27. So when I will be dividing the denominator by 3, I will be dividing the numerator also by 3. So means if I divide 18 by 3, I get 6. So if I divide 18 by 3 and I divide 27 by 3, I get 6 upon 9. So 6 is the value which should be filled here. So by dividing the numerator and denominator with the same number, or by multiplying the numerator and denominator with the same number, we get the equivalent fractions. You may be asking, by why are we learning this? This has got a very important use when we will be moving to the addition and subtraction of the fractions. So this is one of the steps to reach to addition of fractions, right? And sometimes the children start thinking that why the hell we need to learn maths, and why do we require to learn maths? I think the question is very valid. If I look at with the minds of 10-year, 12-year or 14-year-old, children, let me tell you, it is very important subject, one of the very important subject. Addition of fractions, if I talk about. Let's say if I say if you have been given a problem like that, you are having a certain amount of rice which is measured in kilograms or grams, and somebody has been given this part and somebody has been given this part. So what is the part left, or what is the total part amount has been taken by somebody? These are the problems which you will face. I'll give you one more practical problem. The answer to this problem I'll be sharing a little later. Suppose you are a 10 years old child and you come across with a huge pole standing on the roadside or in your courtyard or somewhere, and you have been given one measuring tape, only one measuring tape, which can measure a measuring tape of the which can maximum measure say 5 or 6 feet, or say 150 centimeters, or say 1.5 meters, something like that, or maybe 3 meters maximum, something like that. And you have been asked to measure the height of the pole which has been given, and the pole is very high. Now you must be thinking, you can't climb on the pole to measure the height of the pole because you are very small, and you do not have any equipment to climb on the pole, no ladder or nothing. You do not have any other equipment given, and you are having only a measuring tape. Let me tell you, there is a topic in class 6th and 7th which is being taught, which by using that topic, by learning that topic, you can simply, with a simple click, you can find the height of a very huge pole wherever it is given. So I'll tell you this thing when we'll be reaching to that topic, but I'm just giving you one example that how important the subject is. So coming back to our point, equivalent fractions we are talking about. So this is how the equivalent fractions are being formed. Or if we have to check whether two fractions are equivalent or not, checking equivalence of two fractions, checking equivalence of two fractions. I always tell that wherever you do not understand any particular explanation or anything which it's not very clear to you in my video, you may write your comment and I'll answer you or give you a solution in the comment itself. So that is how we can further learn. So checking equivalence of two fractions, if I have to check two fractions whether they are equivalent or not, 1/2 is a fraction, 3/6 is another fraction, and we need to check whether they are equivalent or not. The simplest method of finding this is, what we'll do, we'll cross multiply. We will cross multiply. So we'll multiply 1/6, we'll multiply 2/3, and we'll find the result. If the result is same, the two fractions are equal fractions. So if the result of cross multiplication is same, if the result of cross multiplication is same, then the fraction is then the fractions are equivalent fractions. And the fractions are equivalent fractions. So this is how we can check the equivalence of two fractions. I'll give you one more example. Supposingly I take two fractions, say 3/4 and 6/7, whether they are equivalent or not. The method is cross multiplication. 3 multiplied by 7, 4 multiplied by 6, 3 7 are 21, 4 6 are 24. So since the values are not same, the resultant values of cross multiplications are not same, so these are not the equivalent fractions, right? So this is how we find whether the two fractions are equivalent or not. So let's move on to the next part of today's video, which is comparing and ordering fractions. Supposingly we are having fractions with the same denominators, like suppose I'm having 9/10 1 by 10, say 7 by 10, say 5 by 10. Supposingly we are having fractions with the same denominator, which is 10, and we have to compare or find out which is smaller and which is greater. So the comparison can go like this, that if the denominators are same, whichever function is having the smaller numerator is a smaller fraction. So between these two, this is smaller. Between these two, this is smaller. Between these two, this is smaller. Right? So 1 by 10, if I arrange them in ascending order, next is 5 by 10, next is 7 by 10, and next is 9 by 10. So if you remember the symbols of greater than, less than, and equal to, this is smaller, this is smaller, this is smaller, like this. If the comparison of fractions we are doing and we are having the fractions with the same denominator, then these are compared like this, that whichever is having the smaller numerator is a smaller fraction, whichever is having a greater numerator is a greater fraction. We can compare it like this. But what if we are having, I'll give you another example where the denominators are not same. Let's say I'm having 9 by 12, 5 by 6, 2 by 3, and 7 by 12. 7 by 12. And we need to arrange them into ascending order or descending order. Means we need to first of all find out which is greater and which is smaller. Right? So if I have to find out, supposingly between two, I'll go by step, otherwise it would be a little difficult for you. Let's do it. Let's first of all find out, say 5 by 6 and 2 by 3 are, which is greater and which is smaller. So whenever we need to find out whether two fractions are equal or not, of which is greater and which is smaller, we need to have same denominator. Without that we can't compare. So to make the denominator same, we are having different methods. What we can do, if I look at this 6, this is 3, 3 2s are 6, right? The equivalent fractions we are talking about, 3 2s are 6. So if I multiply this by 2, the denominator will be same. But you know that if I have to multiply the denominator by a number, then we need to multiply the numerator by also the same number. So in this case, this particular fraction, if I multiply numerator by 2 and denominator by 2, 4 upon 6, now the denominators of these two are same, and we can only compare two fractions when the denominators are same. Now 5 by 6, 4 by 6, 5 by 6 and 4 by 6, of course 4 by 6 is smaller, 5 by 6 is greater. So this is how we do. Now if we are having more than two fractions and we need to find the same denominators, the method I'll tell you what we'll do. We'll take all these denominators and we will find the LCM of these denominators, the least common multiple. I hope you know the method of finding LCM. I'm going to find the LCM of these denominators like this. And now let's start, say 3, 4s are 12, 3 2s are 6, 3 1s are 3, 3 4s are 12. Then I'll take 2, 2s are 4, 2, 2, 1, 4, and then 2, 1 is 2, 1, 1, 1, 1. I hope you know that we have to find the LCM till we do not receive 1 at the end. And now the LCM of these 4 numbers would be, LCM would be 3 into 2 into 2. 3 into 2 into 2. 3 to a 6 to a 12. 12 is LCM. So LCM is the number which we need to achieve in the denominator of each of these fractions to make them equivalent fraction and to compare them. So for that 12 is the LCM. Now we know that 12 is the LCM, right? LCM, let me write here, LCM is equal to 12. So this is already 9 by 12 is no change required. 5 by 6, I want to make the denominator as 12. That means if I multiply the denominator by 2, I'll achieve 12. So when I'll be multiplying the denominator by 2, I'll have to multiply the numerator also with the same number. That means 2. So this is 10 upon 12. The third fraction is 2 by 3. So to achieve number 12 in the denominator, I need to multiply the denominator by 4. 3 by 4. So 2 also I have to multiply with 4. Same number. The numerator and denominators have to be multiplied with the same number. So 8 upon 12. And if I have to take the third number also, fourth fraction also, the fourth fraction is 7 by 12. So it is, I think, the same. No need to multiply it with anything. So the fourth fraction is 7 by 12. This is, so I'm having now 4 fractions. 9 by 12 will remain same. 5 by 6 will become 10 by 12. 2 by 3 will become 8 by 12. And 7 by 12 will remain 7 by 12. Right? So this is how we have achieved the equivalent fraction. And now see, you have got all the denominators as 12. Same. The denominators as same as 12. What was the LCM? And now we can compare these. So the smallest among these is 7 by 12. Then 8 by 12. Then 9 by 12 and then 10 by 12. So if I have to order them, I'll write 7 by 12. Then I'll write 8 by 12. Then I write 9 by 12. And then I write 10 by 12. And this is how we'll order them, compare them. So this is how the comparing and ordering of fractions is being done. Arrange 7 by 3, 7 by 15, 7 by 30 and 7 by 5 and 7 by 5 in ascending order. Ascending order, I hope it is clear to you that ascending order means starting from the smallest reaching to the greatest. Whenever you have to arrange any number or any series of numbers or any fraction or anything in ascending order means the first, the smallest one, then second greater, then next greater, then next greater, and last the highest. Then it is ascending order. For example, 1, 2, 3, 4, 5. For example, 2, 5, 7, 9. For example, 3, 7, 9, 11. Right? This is called ascending order. So again, to compare, we need to have the same denominators, which we do not have right now. We need to find the LCM of these denominators first of all. The denominators are 3, 15, 30, 5. To find the LCM, let us start with 3. 3 ones are 3, 3 5s are 15, 3 times 30, and then 5. Then let's start with 5. 1, 1, 2, 1, and then 2, 1, 1, 1, 1, 1. So LCM is equal to 3 into 5 into 2 is equal to 30. That means now we need to achieve the denominator of each of these 4 fractions as 30. Once we'll achieve that, once the denominators of every fraction is equal, we can very well compare them. So LCM is 30, LCM is 30, right? So let's take 7 by 3. If I have to make the denominator as 30, I need to multiply it with 10. So I'll be multiplying the numerator also with 10. So 3 into 10 is equal to 70 upon 30. Then comes 7 by 15. In this case, 15 multiplied by 2 will give me 30. But when I'll be multiplying 15 by 2, I'll have to multiply 7 also by 2, because the rule is that we need to multiply the numerator and denominator with the same number. So the 14 upon 30, this is how. Next comes 7 by 30. We need not to make any change because the denominator is already 30, and the last, which is 7 by 5, again to make the denominator as 30, I'll be multiplying it with 6. So I'll be multiplying the numerator also with the same number, that is 6. Now 5 6 are 30 and 7 6 are 42. So now I have got 4 fractions: 7 by 30, 14 by 30, 7 by 30 and 42 by 30. 70 by 30, 14 by 30, 7 by 30, 42 by 30. So shall I write this? I love this. So the 4 fractions are now 70 by 30 and then 14 by 30 and then 7 by 30 and then 42 by 30. Now we can compare them because the denominators are equal, and that is 30. So the smallest is 7 by 30, then 14 by 30, then 42 by 30 and then 70 by 30. So 7 by 30 is smaller than 14 by 30, smaller than 42 by 30, smaller than 70 by 30. This is how we arrange them into ascending order. Okay, I think we need to cut short the video till here today. The additions of fractions we will be taking up in the next video, which I'll be uploading the very next day, that is tomorrow. So this is how so a quick recap. What we have done, today we have learned the equivalent fractions and we have learned how to compare the fractions. We have learned that the different looking fractions having the similar value are called equivalent fractions. We have learned that by multiplying the numerator and denominator with the same number, we can find an equivalent fraction. We can also find an equivalent fraction by dividing the numerator and denominator with the same number. We can also check whether the two fractions are equivalent or not by cross multiplying the numerator of one fraction with the denominator of the second fraction, the denominator of the first fraction with the numerator of the second fraction, and if we get the multiplied values as same, they are equivalent fractions. But if the multiplied values are not same, they are not the equivalent fractions. And then we have learned the comparison of fractions and arranging them in ascending or descending order. And for that, we need to make their denominators equal. If the denominators are equal, then the numerators can be compared. Which is having a smaller numerator is a smaller fraction, which is having the greater numerator is a greater fraction. But this comparison can only be done once we have achieved the denominators as equal. If the denominators are not equal, we can make the denominators equal by finding the LCM and then achieving the denominator equal to LCM by multiplying or by dividing the fraction. And when we divide or multiply, we have to divide the both numerators and denominators with the same number. So that's it for today. Thank you very much. Wait for next video. Please subscribe to the channel. Don't forget to press the bell icon and so that you get the notification for the new videos which comes up. Thank you very much.